to Adhyap. My name is Leena and this is my sister.
It's me, Hannah, with you, and today we're here to talk about the root mean square error function. And this works similar to the least square cost function to identify the error between the predicted values y hat and the actual values y. So this is mainly used and mainly needed whenever you're trying to make a model perfect through accuracy wise. And RMSE does do some of its calculations similar to least square cost function, but they're both different at the end. So let me write the equation.
Yeah. So at first Hannah will be writing RMSE, just means that it's RMSE's equation, and then you will identify that it's exactly how we are seeing in the name. So if you have a difficulty to remember how do you write this equation, you can just remember the name, root mean squared error, which is first we have to square root, then we get the mean, which is our residual, also known as, so y minus or subtracted with y hat, and it will be squared. And the only thing that you have to remember is the number of residuals subtracted by 1 has to be divided by the squared residuals.
The reason why we subtract these values by 1 is because we want to go through the values or process these values. Means go through the residuals that we have. But that's not it. We still need to square root the result after dividing these two values. So that's how RMSE works. The first steps are pretty similar to least square cost function, like I said, but soon you'll understand how it exactly works. So let's go with the scenario.
Yeah. Okay. So I'll give a scenario. Let's say that we just trained a model and created a bot named Devo. Actually, Devo is our small little cute friend and she's really good at predicting things. But we'll be using her name here. So the Devo bot is supposed to predict the next 5 days temperature and weather. But remember, RMSE cost functions are only used when converging or training models. And I mean the models that are being trained. Why? Because while training we need to improve a model. How we are doing that? You might have heard of training sets, validation sets and testing sets, and also an epoch. So you can say an epoch is a test for the model, and a model is a student. The student has been given questions and it needs to answer them, and the RMSE is the one that's giving the scores. So if the RMSE is high, then it means that the model isn't doing so good. So we need to improve the model. If it's doing good, then we'll be letting it being converged, and it means it's matured enough to be a trained and pre-trained model. So that's how DevoBot has been trained. So the RMSE function is being used with the testing data here, but you are also free to say that the DevoBot is being trained, because they are exactly the same scenario, just that the DevoBot is being pre-trained here.
So, and we're just testing the Devo model.
Yeah.
So I'll be showing some of the values that the Devo model gave for the next 5 days temperatures. Let's say on Monday she gave 30, in Tuesday she gave 32, Wednesday she gave 33, and Thursday she gave 31. Whereas in Friday she gave 34. Now we waited for those 5 days and finally we got the actual temperatures. Well, looks like Devo was a bit right. So in Monday she was alright, but in Tuesday she got it a bit wrong. It was actually 33. And in Wednesday, she was alright. And in Thursday, again, she got a bit wrong. It was 30. And in Friday, alright. Now, let's try to visualize this in a regression graph, right?
Yes.
So, Monday, 30, 30. In Tuesday, it was 32 and 33. So, 32 and 33. So,
Can I just explain here?
yeah.
So the Y is your outputs, which are the actual weather data that you waited for the days to come. While the predictions from day robot is your Y hat. So you can say 30-30 is exactly in the line because both of the predictions and the actual data is the same. And some are up and down. Well, that means they have a few issues. For example, these are not exactly the same. So that's what these values and data points are projecting.
Okay, so now we'll go to the calculations and actually calculate what's Davu's score on these 5 days predictions. And then we'll really identify whether Davu is ready to be used. So first, as per the equation, we need to subtract these values and square them. So 30 subtracted with 30, it's going to be 0.
So 0 means our residual, but it has to be squared. So if we get a negative value, then it means that it has to become positive. So we can continue our calculation. So that's the main reason for squaring, as you will see now. So don't worry about the zeros because they'll be still considered as a residual, even though their output is still 0.
Okay. So right now we have some zeros and we're not going to really use those values while adding, right? So remember, the reason why we squared is to avoid negative values. So this negative one is going to be a positive one, and when we add that with this one, which is going to be 2, then it will give a result of 2. But in the equation, we also need to make a fraction that will show us that we are going to compute through these values. Here we have 5 values, but out of these 5 values, 3 of them are zeros. Should we consider them or not? Well, we should consider them because these values here is not to avoid the zeros, but it's here to compute the residuals, right? So it will be more like 2 by 4 then, since we have 5 values. Subtracted 1, it's 4. So now what we need to do, we need to divide 2 by 4. And that will result us with a value of 0.5. And if we were to represent that as a fraction, it's going to be considered as 1 by 2. Okay, but the last portion that we are missing, and it looks like we're supposed to do that at the beginning, seems to be square rooting. But actually that's not right. We need to square root at the end, where we will get a result of 0.707. And this is our result here. The reason why we square rooted here itself is because the entire thing will change as per that, right? Because of the denominator, right? So the 0.707 is our result. Just to note that values that are at least from 0.2 to 0.5 are at least alright models. They're all good to go. And models that are near to 1 like 0.9, they wouldn't be that good and still need to be fine-tuned. So right now 0.7 isn't a bad figure for Davu, right?
Yes.
So this is the answer. And yes, the least square cost function is a bit similar based on the calculation wise. At the first steps, it is true that we are doing the same way, but in the end we have different results because of computation, right? Yes, these two are both popular and can be used.
Can I just note something here?
Yeah.
Well, you can see this as 1 divided by square root of 2.
Yeah.
And you can write it this way as well. And one more thing to say is that after we are getting the score, what do? We have to fix the model, right? Well, in the last few videos, we have explained about hypothesis function, which is the one that's predicting these values. Well, you will get a theta there. Theta means the
weights or hyperparameters.
And these will be fine-tuned after getting the score. And that's what our next video will be covering.
Gradient descent, one of the most important functions for solving these issues, because just getting some values and identifying how much error they have isn't so helpful. So we need to use the gradient descent calculation or equation to solve these issues. So I think it's time to wind up.
Yes.
So if this video helped you, then please follow, like, and don't forget to click the bell icon for real-time updates. Whereas, if you want to contact us, then our email IDs and all will be in the description below. But the best way to communicate with us is on LinkedIn. So see you there in the next video of Gradient Descent. Bye!